In our last video, we reviewed the basics of ionic and covalent compounds. And specifically now, we want to make sure that we're okay with this concept of an ion versus an atom. Atoms are neutral. So when we see this term subatomic composition, it basically means like what makes up the atom? What are the subparticles, the protons, neutrons, and electrons that comprise this particle? In a sodium atom, we should have a neutral particle, which I think we mentioned in the last video. Sodium atoms. Sodium is element number 11. So we would say there are 11 protons. There should be 11 electrons. To get the number of neutrons, we look at the atomic mass, which on a periodic table is going to be a decimal, and that represents a weighted average of all the isotopes that exist. Isotopes are atoms with different masses. They have different amounts of neutrons. The periodic table will show a mass that reflects not only the different masses of isotopes available, but also their abundance in nature. We'll get into isotopes more in another chapter when we look more specifically at atomic structure. But for now, we can kind of round these. If we round them, we're usually rounding them to the most abundant, the most stable isotope. So for sodium number 11, it's really close to an atomic mass of 23. I'm going to use 23 for this atomic mass. The mass number should really reflect the protons and the neutrons. The electrons are so small that their mass is pretty insignificant to the overall mass of the atom. So when I say that the mass of a sodium atom is 23 AMUs, atomic mass units, that must mean there are 11 protons per atom. And we're going to say 12 neutrons. Neutral neutrons. So that all comes off a periodic table. There's some of these in the homework. You'll just need a periodic table. Anyone will do. Now looking at ions. Zinc. 2+, or you can say +2. Either is fine. It kind of depends on what you're used to. This book will use 2+ quite a bit, or like a 3+ or 3-. If you're used to +2, that is fine. I usually say +2. This is zinc. If I look at the periodic table, zinc's atomic number is 30. So zinc must have 30 positive protons. Now we are not neutral. We have a charge of +2. That's going to affect the electron count. So in order to have a positive charge, it must mean that I have extra protons. I have 2 extra protons. We have 28 electrons. So when I do a comparison of protons versus electrons, I should end up with the overall charge on the particle. The neutrons can come from the atomic mass again. The fact that this is an ion has no change to the number of neutrons. So again, we'll kind of round this. Zinc's atomic mass is maybe about 65.39. So if we round that to about 65, we're probably rounding it to the most stable isotope. So if there are 30 protons, we must have about 35 neutral neutrons. Oh, nice. And the last one, nitrogen. And again, you can say 3- or you can say -3. I guess that's a habit that I just can't break. Your textbook will usually say like 3-. But if I write -3, it's the same thing. Nitrogen is element number 7. So there must be 7 positive protons. This is not a neutral atom. It's an ion. We have a charge of -3, which must mean that there are 3 extra negative electrons, giving us 10. If I round the atomic mass of nitrogen, I'd be looking at about 14. It's really close to 14. That tells me there must be about 7 positive protons and 7 neutral neutrons. Notice, too, that whether it's an atom or an ion, The protons and the neutrons do not have to add up. The neutrons add mass and stability to the atom. And depending on how big the atom is, often there's more neutrons. That's okay. The neutrons will kind of help, they help kind of break apart any kind of repulsion in the nucleus that occurs from these positive protons or these like-charged particles being so close to each other. So often as you get bigger and bigger atoms, you may find more neutrons. And that's kind of why the more protons you have, the more repulsion of like-charged particles. So these neutrons will add mass, stability, and they'll also kind of help to ease some of that repulsion so our nucleus is relatively stable. So it's okay to have different amounts of neutrons versus protons, especially even if it's a neutral atom, that's fine. If you're dealing with an ion, make sure you watch the charge. That'll affect your electron count, whether I need to gain or lose electrons.